Hey everybody, and welcome back to Engineering Economics. In this unit, we're going to be talking about choosing the best alternative. So basically, we're going to learn how to compare things that might have a different time period or a different time value of money, and we're going to take those and convert them so that we can compare them to each other. So rather than comparing apples to oranges, we're going to make it so we can compare apples to apples, etc. So we've spent the last several units talking about present value, uniform series. We're going to talk about future series. So now we're going to take all of that information and with these lovely tables that we have in the back of our textbook, and we're going to put all of that now into Excel. So we're going to bring it all together. So if you've never worked in Excel before, that's fine. I'll step you through it, and there are tons of YouTube videos out there that can also step you through it. But my purpose is to help you with the portion of Excel that deals specifically with the time value of money. So we're going to get into some different formulas. So in the back of your textbook, it has this summary table for you, but thought I would throw it out here. So here in this column, we show to find a present value, I'm going to use the Excel function PV. So you'll notice the negative in front of that. We'll talk about that later, but the default Excel function is negative PV, and the inputs are interest rate, period, uniform value, right? I usually think of this as an annual value, but sometimes it can be monthly. So uniform value and future value. So the nice thing that we'll get into in a few minutes is you don't need an annual value or a uniform value and a future value. You can just use this formula for one or the other. So it's really useful. So then here to find my A, we will then use this formula that is called payment. So to find a regular payment value or a regular benefit value, I would use this formula here with, once again, interest rate, period, present value, future value. Okay, then to find future value, it would once again be a negative future value, interest rate, period, annual value, or uniform series, and then present value. So then here we would find our number of periods. So we have these inputs. Here we would have I, and I would use my rate formula. And then here to find my net present value, I would use this, and we'll show an example of this today. And these in here just mean cash flow 1 through cash flow whatever. So you can either choose to input those individually or put those in Excel and just highlight all of them. And then here to find my internal rate of return, we would use the same formula, but the CF through CFN again would be my cash flow values. Okay, so those are going to be the main formulas that we use throughout this chapter. So I'm going to do a bunch of kind of basic examples just to show how these work, because the stuff we're going to do later combines them all, and I just want to show you one at a time. So I've thrown together some pretty simple examples here. So you invest $1,000 at 6% annual interest for 5 years. What will it be worth? Okay, so I'm putting in $1,000 now, and I want to know what it's going to be worth in the future. So I want a future value, and you'll see here I kind of broke down my given values. So I'm going to say equals, and you can put your negative in either location. Your book recommends putting it at the beginning like this, and so then I would put 6%, and always remember this needs to be formatted like a percent. So it won't work just to say 6 because it really will want it then as a decimal, so put it as a percentage value here. So 6% for 5 years. And then if you remember, the input here is the uniform series. So I'm going to leave that blank. And then I'm going to say my present value is $1,000. Okay, so that looks like this. So that means then in 5 years from now, my $1,000 that I have now is worth $1,300. So I just wanted to show you that it would equal the same thing if I did 6% for 5 years, nothing annually, but then negative $1,000, because I would think about that negative as a cost. So you'll notice there's no negative at the beginning, but there is a negative for this value because it's a cost. And those turn out to give you the same value. So you can then compare which way you want to do this, where you want to put that negative, but it will give you the same thing. Okay, so now we're going to use our present value formula. So it says you want to know how much you need to invest now to get $1,500 in 4 years at 7% annual interest. Okay, so once again, I am looking for a present value, kind of the opposite of the last time. If I want $1,500 in 4 years, how much do I need to put in the bank now? Okay, so I would then use my present value formula. So I'm going to do the negative inside the function. You can do it wherever you want. So that would then be at 7% interest. And there's no value annually or, a uniform series. And then I'm going to put in after 4 years, I would have $1,500. So the question then is that a cost? Is that not a cost? If that were a cost, I would put my negative there, but I don't really view that as a cost, so I'm going to put my negative out front. It doesn't hugely matter, right? So now we're saying I would have to put into the bank $1,144 to get $1,500 in 4 years. Okay, so next then is my payment. So this then is like the annual value, that A value that we use in our kind of factor system. So I take a loan of $10,000 at 5% annual interest to be paid over 4 years, and I need to know what is my annual payment. So this is actually a really useful formula for you to know on your own for like getting a car loan, motorcycle loan, house loan, etc. So I would then say equals PMT and 5% and comma 4 comma and then $10,000. So notice I don't use the comma delineator here because that would tell my equation I have another input. Okay, so I would hit enter. Okay, so then it says, okay, my annual payment is $2,800 ish. So notice it's a negative value. So that makes sense because it's a payment I'm going to make to someone every year. The red in parentheses in Excel tells you negative. So you could get around that like the book recommends and put that. That just tells you it's an annual payment, but it's not negative. Just pay close attention to your negatives and positives this chapter. Okay, next is my net present value. So with my net present value, remember this is the one that's going to use cash flows in my inputs. So for this one, I'm going to say equals net present value. And I'm looking at, I guess we didn't even read it. What's the net present value of a project that requires an initial investment of $5,000 and generates $1,500 in cash flows each year for 5 years using a discount rate of 8%. Okay, so that would look like this then if I say 8% and then I have these values of 1,500. So that would be cash flow 1, cash flow 2, cash flow 3, cash flow 4, cash flow 5. Okay, so that's over 5 years. And then I still have this initial investment of $5,000. So I'm going to say minus 5,000. So you'll notice these 1,500 values are positive, meaning they're incoming. They generate this much. It's a benefit to me. But then this 5,000 is a negative because I'm paying it. Anyway, so they would be opposite. Okay, so the net present value of that project would be a positive value, $989. Okay, so our last example then is going to be find the interest rate. Okay, I guess I have 2 more. So this is problem 5. You invest $5,000 and get back $7,000 in 5 years. What's the annual interest rate? So this time I'm going to use my rate equation, and you'll notice the prompts down here in Excel. It will show you what's going to go in what field if you don't remember, so don't stress that. So my first value is not interest rate this time because I'm looking for an interest rate. So this time my first input is going to be this N per, or number of periods. So I'm going to say for 5 years, and this time it asks for my uniform series or my payment. So I'm going to say nothing. So I'm just going to leave that field blank. And then PV will be a negative $5,000. So I invest it, I pay it, so that's a negative to my bank account. And then the future value is 7,000. Okay, so notice I'm just following these inputs as I go. So my interest rate then is 7%. So if I want to, I could probably increase this and maybe see what it is with more decimal places. Usually banks report to 2 decimal places like this, so 6.96%, or roughly 7%. Okay, the last one then is going to be my number of periods. So how many years will it take to grow $2,000 to $3,000 at 5%? So this is a really good one to do for all of us that are maybe considering putting money in some kind of stock, or in a, maybe not a stock because that's more fluctuating, but in something like a CD or a money market. We can ask, how long will it take this much amount to grow to this much amount? Okay, so I could say number of periods, and my interest rate is 5%. And then I'm going to leave that field blank because I don't have a uniform series or an annual amount. And then my initial value is 2,000. And since it's a cost, I'm going to make it negative. And then I would say my final value will be 3,000. So that then is 8.31 years. And you could convert those decimals to be months out of the year. But so there you go. That's kind of how you would use these engineering economic Excel functions. Let me know if you have questions.